What up? What up? Who's ready for another lecture? I know I am. All right. So we want to do classes today. We're getting into it, and this is really where the course starts heating up. We had two lectures of 115 review, but introducing the Java language and everything that entails. Kind of a warm up lecture to 116 content and unit testing. Unit testing I don't think it's too complex of a concept, but it is new. It is a 116 topic. Classes, this is where we dive into it. There's so many concepts that I gotta cover today. There's just a lot to learn. And today's lecture, especially having just gone through it for the 8 a.m. lecture, in a summer class with 2.5 hours of just nonstop, it's probably overwhelming. this is this is probably a pretty overwhelming lecture if you're learning all this stuff for the first time. Before we get into that, just a little bit of stats. We had the expected deadline for task 1 this morning is passed. And just to give you an idea where everybody's at, we had 40, make sure I'm reading this right, 45 students did complete it before the expected deadline. So I'm happy to see that. That's definitely good. Definitely could be worse, I should say. 2 students have started the assignment but didn't finish it, and one of those is kind of a special case. So not very many people attempted it but didn't finish it, which is good to see. I like to see that. The stat that's a bit scarier is the remaining 12 students who, I wonder if somebody submitted before the first lecture. I feel like the numbers were a little different during the first lecture. The remaining 12 students who did not even make a submission, that's, I mean, those students are going to fail. Like, I meant to prepare an email and send it to them right at the deadline and say, hey, bro, you're going to fail. You can't do this. This isn't going to work for you. It's not going to work the way you expect it to. And even if they do pass, they're throwing away application objectives. I don't want to dwell on too long because those 12 students, let's face it, they're not watching lectures. They're not going to hear my voice. If they do hear this, it's going to be too late anyway. But they got to get their act together. They got to get working on the course, because if they didn't even make a submission, logic dictates that they didn't even start the assignment. That's bad. Those of you who did finish it, which is probably everybody who's hearing me live at least, good job. Keep it up. The course does not let up. It's just going to keep, those deadlines just keep coming and coming. So don't let up. Keep at it. You got to go full speed for the next 4 weeks and get everything done. Which I keep forgetting to mention this. I remembered it in the morning lecture, and I'm going to remember it now. But I forgot the first 3 lectures. Just to put it into perspective, there should be 12 lectures. We have 6 weeks in Tuesday, Thursday lectures. One of those we lose for a holiday, and one of those is the final exam. So it's really only 10 lectures, and one of those is a half lecture because of the midterm. So it's basically like 9.5 lectures. But we'll round up to 10. We'll call it 10 lectures. And today is the 4th one, meaning after today's lecture, we are 40% of the way done with the course. That's how fast the summer moves. By next Tuesday, we're going to be at that 50% mark. It'll be half of the things that I need to lecture about it's going to be out there already. That's how quickly this goes. There's no time to just screw around for a week or even a day, really. You really got to be working at it and keeping up to date on everything. All right, so that's enough announcements. We got a lot to cover today, so let's get into this. Let's get our new package, lecture, and let's do this thing. Player. Let's do the player example. And this one's an interesting to do live coding. Because it's such a conceptual lecture. It's going to be interesting for me to do it all in code, which I'm looking forward to. I'm excited about. And I'm admittedly a little nervous, but I did it last summer. I'll do it again here. I'm just always worried I'm going to forget like one thing. ToString, I think, is the one thing that I'm most likely to forget. But even if I do forget it, that comes up in inheritance lecture anyway. I talk about ToString in depth in that one. So what we want to do, we want to start talking about objects. We want to start talking about classes and objects. Now, we've talked about classes because it's Java. We have to talk about classes or else we can't write any Java code. So everything has to be contained in a class. But we have been using classes just as a container for static methods, which is our way of kind of pretending that Java is more like Python and pretending that our methods are more like functions. But today we're moving past that and actually using classes for their intended purpose, which is effectively a blueprint to be able to create objects. And we've seen this oh my. And we've seen this before. Let me get my main method right away. Is array list of integer r equals new array list. Like, we've seen this before. Like, the array list class, if I control click to this, I can get to the array list class. And this array list class is designed to create objects. That's why this class exists. It doesn't have any static methods like we've been using classes for. It only exists to be able to create objects of type array list. And that's what we want to do today, is write a class, oops, that's the wrong one, is write a class that's used to create objects. So what we want to do, what I want to be able to do today is say player, I'm trying to think of what I called them, I'll just call them player 1. P1 is fine, because I have to type this in player 1. I have to type it in a memory diagram later, so I don't want too many characters just because I don't want to type as much, but it's fine. I could type player 1. Equals new player. This is what I want to be able to do, and actually I want to give it parameters, but we'll get to that. We'll get to that later. Instantiation of utility class player. Yeah, it's saying, dude, you didn't set this up for this. I'll let you do it, but there's no point to it. So that's what I want to do. I want to write my own class that's used to create objects of that class type. That's what I want to do. And specifically, I want to be able to create, even more than that, I want to be able to create multiple objects of the same type. So this is what I want to do. Just like I can have multiple array lists. Oops. Just like I can have multiple array lists. And these array lists can have different sets of values. They can store different sets of data. I want the same thing with my own custom classes, because I want to create a player class. What I want to create today is a player that's going to have like a player in a game. It's going to have max HP, current HP, and name are the three values I want my players to have. And I want each player to have their own copies of these variables, because if I'm going to write a 2-player game like this, I want player 1 and player 2 to have their own HP, their own max HP, and their own names. So I can have 2 players with different names, and importantly, they're going to have their own copies of all these variables. So importantly, let's say this is a fighting game where player 1 and player 2 are fighting to see who's going to win, or even 4 players like a Smash Bros or something. I want each player to be able to have their own HP, because if they share an HP variable, nobody's going to be able to win the game. They're all going to die at the same exact time once that HP reaches 0. Player 1 will have a variable HP, and player 2 will have a different variable HP, so they can both have HP that varies independently, and a name. Those players should have different names as well. So that's what I want, is a class that's going to behave like this, that's going to let me create these objects. So that's what I want. And my main method is kind of logically separated from everything else I'll write today. But I'll have my main method here so we can see how this code is going to be used as we're writing it. So that's what I want. That's my goal. I want these 2 players to have these 3 variables and to be able to behave independently. how are we going to do that? And first of all, what even is, so this is, when I say new player, I'm creating a new object of type player, just like new array list created a new array list, object of type array list, and that went on the heap. Spoilers, we're going to see a lot of heap action with references. That will be a huge topic for the rest of the semester. And an object is a collection of state and behavior, where state is all the variables of that object, and behavior, I don't have any yet, but behavior is going to be all of the methods for that object. So an object is a container, and really a class is too, a container for state and behavior, variables and methods, and that's what we want to write here. So our state here is going to be these 3 variables, and I'm going to add this right now, but I'll talk about it later. These variables are going to be private. I have a lot to talk about this later when we get to that, but let me just sideline that for now and say they're private. Now, any variables that are declared outside of all of the methods in your class, these are going to become special variables called instance variables. They're instance variables because each instance of this class or object of this type, each object is going to have its own copy of every instance variable defined in that class. So player 1 has copies of these 3, player 2 has copies of these 3 variables. And we do that by putting them outside of all of the methods. We haven't declared any variables out there yet. Well, actually, no, I didn't even do that in this lecture, the epsilon. I didn't create epsilon in this lecture. So all variables outside of the methods become instance variables. Now, these variables have a lot of different names depending on who you ask and depending on when you ask them, as I'll explain in a second. They can be called instance variables. They can be called object variables, which I might start calling them object variables. They can be called, I'm blanking. This is where my slides would help. I'm blanking on the other one. Oh, state variables. That's what I used to call them in 116. State variables or fields. A lot of people like to call them fields, including myself. I'm going to stay consistent in 116 and call them instance variables. But if you hear them called by any other name, if somebody's talking about state variables or fields, they mean the same thing. They're talking about these variables here that belong to your objects on the heap. So these are our instance variables, I'll call them in 116. And if you see me in an upper level class and I'm talking about the same thing, I'll usually call them fields at the higher levels because that's what I prefer to call these, just because field is one syllable and it's easier to say, just rolls off the tongue easier. But I think field is the least descriptive name for them. It has really no intrinsic meaning, to me at least. It comes from the world of mathematics. Mathematicians like calling these fields, and sometimes we call them fields too. But I like it because for the brevity. In 116, I like to call them instance variables because it's a little more descriptive of what they actually are. They're variables that belong to each instance of that class. So those are instance variables. And next, let's get some of the behavior in this class. Excuse me. And lost my train of thought. Oh, I want to, good as time as any is right now, is explain my usual lecturing style. Usually this is in a whole week, but obviously in the summer it's one lecture. So in the context of one lecture, what I like to do is get all of the concept out there quickly and then spend the rest of the time reinforcing the concepts. Now today is so concept heavy that the first half of lecture will be concepts and then the second half will be reinforcing those concepts. But if the beginning of a lecture is very overwhelming because I'm throwing a lot at you, don't panic too much. Because at some point in that lecture, I'm going to stop introducing new things and go over everything that we talked about a couple of times in different ways with a memory diagram, with some more examples. We're going to go over everything. But right now we got to get public versus private, static versus non-static, constructors, constructor calls, references, heaps, encapsulation. There's just a whole bunch of stuff that we need to talk about, and I'm going to get it all out there right now. So we're calling a constructor. I mentioned this with the array list class, that when we say new, what we're doing is creating a new object on the heap, and what's going to follow is a constructor call, which is a call to a special method that exists in that class. And now we're flipping this around and going to the other side with array list and hash map we called constructors. Now we're on the other side where we're going to write a constructor, and a constructor kind of similar to a main method in that there is a very specific way to write one, and if you follow that specific way, you have yourself a constructor, and if you don't write it in that specific way, you don't have a constructor. So what a constructor is, it's going to be, ours are going to be public. We're actually going to see a private constructor later today, but it's kind of an anomaly. And it's going to be a method with a name that exactly matches the class name. So when I say new player to call this constructor, I'm not really specifying the class name. What I'm doing is calling the constructor, which is a method that has a name that has to exactly match the class name. So it will be the class name, but this is strictly just a method call to a special method that is a constructor. So when I call this constructor, I'm going to get this method called. So this is my constructor. It has two special properties that make it a constructor, or two special features that tell Java we're writing a constructor. One, I just mentioned, the name of the method has to exactly match the name of the class, meaning this will be our rare method that will start with a capital letter. Other than that, all methods are going to start with lowercase letters if you're following good proper naming conventions. And we don't specify a return type. That's not a typo. You just don't put a return type on your constructors. If we put a return type here, what's the warning? Warning's probably don't call your method that. Yeah, it says don't name your method that, because this is no longer a constructor. Just out of curiosity. Yeah. So this, I haven't tried this, so let me do this typical here call. Since we're in the code, I kind of am curious what happens here. And yeah, so we don't have ourselves a constructor. This method is not a constructor, so it's not being called. We didn't get our print statement executed. This method isn't being called when we create a new object of the type. It's only called if we don't have a return type. Now it's a constructor, and now that's what's being called when we create our new objects of this type. So we have to not have a return type. Any return type is going to make this no longer a constructor. I don't need my import here. And when we call a constructor, we want to initialize our instance variables. The primary purpose of a constructor is to initialize those variables. So we want to take some parameters here. Now first, we don't have to. If I want to hard code these, like we declared these variables but didn't assign them any values, but we can. We're perfectly allowed to assign these values right in line. And then we can take, maybe we want to just specify the name. We want to say every player in our game has 10 max HP and starts at full health. But they can have different names. So we can take the name as a constructor parameter. I'll circle back to explain what the keyword this is, because I have a lot to talk about that. For now, just let's get this example. This will initialize this instance variable to the parameter of the constructor. And then what we want is, I'm going to change this a little bit. Kind of, oops, that's a keyword. I can't use class. Type. Job works. Job. Yeah, I'm overthinking that one, but whatever. Dark Knight and I kind of ruined the context of this then, but just because that bugs me, let me change this back to name, and I'll just put their titles in their name. That works. Dark Knight, just so I can keep my context of the example. Dark Knight Cecil and Dragoon Kane. That works. And I'll cut and paste that when I do the trace, I guess. And now what we're doing is taking in the constructor, we're going to take any parameters that we want to initialize on a per object basis. That's what we're going to put in the constructor parameters. So if I want all of my characters, all my players to have max HP of 10 and start at full health, but I want them to have different names, I'm just going to put name as a constructor parameter and have the constructor initialize the variable for name only. Now both of these players will have max HP and HP of 10, but they will have different values for their name variable depending on what we give it the constructor. And if we want to initialize more things, we can initialize more in the constructor. So say I also want them to have different max HP. If you want different initial values on a per object basis, put it as a constructor parameter, and then we can have these players have different max HP. So maybe Kane has more HP than Cecil. We're going to specify that as a constructor parameter, and then in our constructor, we can set the max HP and HP based on that constructor parameter. And and they can still start at full health. If we don't want them to start at full health, we can add a third parameter here and have that information as well. Can you quickly explain why I did just explain that. Let me try to reword it to make sure it makes more sense. So if we initialize, now that I'm doing that in the constructor, I want to get rid of these. But say I didn't, before I did this, let me get rid of name because it's the least things to change. I don't think there's an H in it. So why would I do it in the constructor instead of doing it up here? Well, if I initialize it up here, then every object I create is going to have the same name. So I can specify the name, but I can only specify it once for every single object I create. And when I'm creating two different objects, I don't want them to both have the name Rydia. I don't want either of these ones to have the name Rydia. So I'm going to put it as a constructor parameter so each object I create can have a different value for that instance variable. So whenever that's the case, we'll move it to be a constructor parameter instead of initializing it inline up here. Now we can specify that value for every single object we create, which we did with, well, I guess you didn't necessarily do that, but most of you did in task 1 when you're testing the average method. You're going to create array lists and use that constructor that takes that arrays.asList and specify the values. So you're specifying those values in the constructor to create array lists with different initial states. And we do that using constructor parameters. So name, I want them to all be different. So I'm going to put that as a constructor parameter. Why does HP equal max HP instead of HP? Well, because I don't have HP here. I could add a third parameter. So I can do this and then specify HP when I call the constructor. That's an option that we have, but I'm saying as a feature of this fictitious game that we're creating, I'm going to start everybody at full health because usually that's how games behave. You're going to spawn in at full health. So since we're spawning in at full health, I'm going to say, you don't have to give me HP. I'm just going to initialize your hit points at your max hit points. So you're always going to start off at full health. So since that's the feature I want, I'm only going to ask for 2 values for the constructor and then use max HP for both max HP and HP. And then as the game goes on, presumably their HP would decrease and start changing, but their max HP probably won't change. Depending on what game. I guess I'm setting this up as a JRPG, so as they level up, their max HP would increase as well. It's a common mistake when we get to the memory diagram that I'll point out a lot. Since HP is not a constructor parameter, HP does not go in the stack frame for the constructor. If I gave this code to 100 students to trace, like I feel like 50 of them will put HP in the constructor stack frame when there's no variable for HP. There's a variable for HP on the heap as part of the object, but not in the stack frame for the constructor call. That sentence is probably pretty confusing to you at this point, but that one will clear up when we get to the memory diagram, when we get to the trace. That one should make a lot more sense. All right, so here's our constructor. And that's it. That's the full constructor. So the keyword this. Let's talk about the keyword this. Yeah, without the slides, I just have to remember my order. Let's talk about the keyword. Shit, I left my dog outside. I'm going to have to get him in a minute. The keyword this. Then I want to talk about public versus private, and then static versus non-static. That's the order I'm going in here. All right, so the keyword this is always a reference to the object that called the method. And this is the big difference, literally the keyword this is the big difference between methods and functions. So I've been using the word method all semester, and I said, don't worry about it. If I say method and you hear function, that's fine. And that's still fine even after we learn this, after we learn the distinction. The distinction is a method is part of a class, and whenever it's called, it's going to have a reference to its context of how it was called in the keyword this. In the case of a constructor, this is a reference to the object that's being constructed, that's being created. And then the dot operator does what it always does. It says, what's to the left of me is a reference. Take me to your object. This is a keyword that stores a reference. And you can think of this as a variable. If you ignore that it's a keyword at all and just think of this as a variable that just comes out of nowhere, it just appears, it just is there available to you. And it stores a reference to the object that called this method. The dot operator takes you to its object, and then we're modifying the max HP instance variable for that object. This is different than just max HP that I have on the right-hand side, which is going to refer to the max HP variable in the stack frame because we didn't head over to the object on the heap using the dot operator. So this max HP is going to be the one in the stack frame. Again, that'll be a little more clear when we get to the memory diagram, when you can see that there are two max HP variables in memory, one in the stack and one on the heap. So if that doesn't make sense, I think the memory diagram will help once we have all the visuals as well. But the keyword this is always a reference to the object that called the method. Public versus private. Let me let my dog in real quick. Just give me 1 second. And we're back. He always wants to go out between lectures. I'm like, it's dangerous. Because sometimes I forget. All right. So we have public versus private. Public we talked about a bit. This means that the code can be called. Let's create another class here just to emphasize this point. Let's call it main and put a main method over here. What public means is that that code can be accessed from anywhere. We can, in another class, we can call that code, and we don't have to worry about being able to access it or not. So the constructor here, let's just move this whole main method over actually. So the constructor is public, meaning that we can call this constructor from anywhere. So here I am outside of the code for this class, but I can still access anything that's public for these in this class. As opposed to private, when something is private, which methods can be private. Like if we made this constructor private, now we can no longer access that from outside of the class. We can't access it at all, except within the class itself. So when something's so as opposed to private means that you can only access that variable or method, or call that method, from within the class. So from the open brace defining that class to the closing brace ending that definition of that class. If you're within those two braces, you can access the private methods and variables. If you're outside those two braces, you cannot. That's where the line is drawn for private. So I can access max HP, HP, and name, these three instance variables, from the constructor because the constructor lives inside of this class. But if I'm outside of that class in some other code that's using this class, player1.hp, I can't do that. I'm not allowed to access that because it's a private variable. Has private access, can't access it. Not allowed. But this is how we want to interact with our code. Like, we're done with the single file programs like you see in 115. That's really not how programming works. Like, programs are multi-file programs, like in almost every case, except for just little toy scripts that you can whip up and stuff. Most programs are going to be multi-file. And you're writing, especially when you're writing classes, you're writing this class so it can be used in another class. We're going to create objects over here. We have the ArrayList class, but the ArrayList class doesn't use itself. We have other code and other files and other classes that's going to use the ArrayList class to be able to create ArrayList objects. Same with our player. We're going to have some graphics engine that's going to handle player instances that's going to need to know like HP and max HP so it can and name so it can display on the UI the name of the player and give a health bar for them. The physics engine is going to have to work with the player to be able to move them around in the game world. There's going to be some combat engine that's going to need to modify the HP of the player as they're competing with another player or enemies. There's going to be a lot of other code that needs to access this code. So why the hell did we make these private? And we just basically just said, you have to access this stuff, but we ain't gonna let you. You're not allowed to access it. I gotta finish this tea. Too much of a distraction when I'm sipping that the whole time. I spilled it on myself too. So why are these private? Like, how the hell is this code over here going to be able to access these variables or even read them? Like, how are we even going to read HP to be able to display it to the actual user of this game, the player, the human player? How are we even going to do that? Well, the answer is getters and setters. If you've messed around with Java at all, you've probably come across these and you probably don't like them. But let's get our getters and setters out here. So public... I'm going to write a getter. I'll just do these in order. For max HP, there's going to be a public method, so it can be accessed over here. And it's going to return the value of max HP, and by convention, it's going to be called get max HP. It's going to take no parameters, and it's going to return this dot max HP. And that's our first getter method. Now over here, I need to get player 1's max HP. I can do player1 dot get max HP, and this I'm allowed to call. I can run this code and be able to display max HP to the screen. And if I need to modify a value, public void, setters are going to return void, which will be very important in a minute. I'll have a lot to say about it. Set max HP. This is going to take the new value for HP, and it'll set the instance variable equal to that parameter. This is our first setter method, and we'll have these for, it's going to be quicker to duplicate these. Probably not. Get HP, which a lowercase HP, 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 name, name, string, string, name with a capital N, name, name, name. So these are our getters and setters. Now if we want to change the HP, so if player 1 is attacking player 2, player 2 dot set HP to player 2 dot get HP minus 4. Let's say Cecil does 4 damage. And then we want to, just to verify that player 2 got hit, player 2 dot get HP. This is how we're going to access those instance variables, is through our getters and setters. And now, uh-oh. Player 2 set HP. No, what happened? Set HP, this dot HP, get HP. Whoa, what went wrong here? Let's say 10. Set HP. Wow, this is like the simplest code. How do I have a mistake here? This dot HP. Morning, Midby? Morning. This is not where we're supposed to be stuck. Player 2 set HP. Hey, when we have a bug, guess what I like to do? Run the debugger. Alright, we get an impromptu debugger lesson here because I gotta figure out, it's gotta be a typo, but I'm not seeing it. So, if you can't eyeball an error, this is what I like to do, is run the debugger. So we can see our two objects, one at 944 and one at 945. So they're different locations, and they each have their own copies of all of the instance variables. And I just can't do math is the problem. So the debugger showed me right away. So player 2 has HP of 14, so once I dealt 4 damage, it's down to 10. So everything worked the way it was supposed to. But let's still go through the debugger. So I can step through this. When I get two methods like this, it's going to ask me which one I want to go to. I'm going to go to get HP. It's going to return this .hp, which is 14. So I return that, subtract 4. Set HP is getting 10. This .hp is 14. So I'm setting it to its value minus 4. And then when that returns, player 2 has HP of 10, 4 less than their max HP, their initial HP. And everything worked exactly as it was expected to work, and I was just not seeing it. Because I was thinking they were both starting at 10 HP. Okay, so everything's fine. I was panicked for nothing. Let's, just to make this a little more visible that something's happening. Okay, now they have less HP. Okay. Why would we ever use getters and setters? Why not just make these public? Well, you're usually going to be working on a team when this. So when I first learned getters and setters, my instructor just said, use getters and setters, that's what you do. Just do it. They didn't say it as aggressively like that, but they didn't go into the explanation. So I always like to go into the explanation of why we use these getters and setters, and specifically in Java. Why do we use these in Java? But if I gave this same lesson in Python, and I used to give the same exact lesson in Scala, I won't use getters and setters. So why in Java? Like why do we do this stuff? So let me explain that. It takes a bit, but we're doing this. So player 1, if HP is public, you're going to be working on a team, you're writing the player class, and the person in charge of the graphics engine, the GUI, the graphical user interface, the person in charge of the combat engine and all combat mechanics and physics engine and all that stuff, they're all going to be different people who are going to be using your code and accessing objects of your type. And somewhere in there, especially the combat engine developer, might do something like player 1 HP equals, I didn't count how many zeros I did, 10 million. S out player 1 dot, and I'll use the getter here, get HP. And they're going to set that HP to some ridiculous value. Probably on accident. So they probably have some complex equations and stuff that determine how much damage is being dealt and how much healing is being done when you cast like healing spells and drink potions and stuff. They're probably doing some calculations and saying, okay, whatever your HP was, add 10 million to it because that's what the damage calculator pumped out, and then they're going to set the HP to that value. So why use getters and setters? In one word, it's for control. When somebody does this, you don't want it to break the code. What I don't want is for somebody to set HP to some value that's higher than max HP. So what I'm going to do is not give them access to the instance variable. I'm going to make this private. Actually, let's keep it public for now. Let's keep it public for now. But in the setter, what I'm going to do, if I get myself in this situation, I got public instance variables, somebody did something dumb like this, and what I want to do is go to my setter, create a setter if I don't have one yet, and then do my check here. Say if HP is greater than this dot max HP, then this dot HP equals this dot max HP. So I'm going to cap out their health. They can't set it to a value greater than max HP. And if we're all good with that, then this dot HP equals HP. Semicolon. So now, only if we've exceeded, so if they exceeded max HP, we're going to cap their health out at max HP and not allow anyone to overheal. They can't heal to some value higher than their max HP. But now, what am I going to do about this? Because this code already exists that someone else on my team already wrote. What am I going to do? Because this is kind of a tricky spot. Because what you pretty much have to do is send out emails and text messages, like on whatever chat app your team uses, or do the old-fashioned walk to their office and knock on their door and tell them, hey, stop using my instance variable. Can you please use my setter instead? Because I added some sanitation to the inputs, and I'd really like it if you called my setter instead. Because you have no control over their code, and especially if this is being done in hundreds of places throughout the whole code base, and then you realize that you want to sanitize the inputs, you don't have any recourse. There's nothing you can do here once all that code's out there except office to office. Hey, I'm going to make my instance variables private now. Stop accessing them directly. And that's a pain. That's annoying to do. What you want to do instead, because once you make your instance variables public, there's no going back. Once this code is written, you can't just make this private because now you broke the project. Now the code doesn't compile anymore. Nobody can run the game without going through and fixing all this stuff. So that's a pain, and everybody on your team is going to get mad at you at that point. So what we do instead is we force everyone to go through the getters and setters, even if we don't use them. So I'm not using anything with max HP. The getters and setters are doing the same thing that direct variable access would do, but I'm setting up my getters and setters to leave myself options down the road. So if I do want to sanitize my inputs like I want to do with set HP, I have that option later. Maybe I want max HP to not be able to be set to more than 999 or 9,999. I can do that in this method right here. And if I'm forcing everyone to use my getters and setters already, then all that other code that uses my code automatically gets that sanitation. So it gives me the control to be able to affect how my variables are being set. So nobody ever gets to write this code. They have to do player1.setHP to 10 million. My sanitation kicks in, and now that only gets set to 10 because that's the max HP for player 1. So now even when their damage calculators pump out these crazy numbers, my sanitation is going to kick in and prevent any issues from occurring. So that's why we use getters and setters, is to give us that control. Even if we don't need it right away, we set up our getters and setters in case we want it in the future. And then in Java, your instance variables are always going to be private. And there's some exceptions to this. Sometimes we'll make them protected, which is something I'll bring up briefly this semester, but I won't really talk about. Sometimes we'll make them protected, but we will have some control over these variables. We will not make them public. It's not the Java way to do it. Now, I say the Java way to do it. In other languages, we don't do this because other languages have mechanics to be able to add getters and setters after the fact. So even if somebody does player1.hp equals 10 million, we can add some extra code after the fact that makes that code with that variable assignment syntax still call a setter method. So we don't have the same need as we do in Java. Java has no such way of changing that variable assignment syntax to actually be a method call to a setter. So in Java, we're setting up our getters and setters. So to sanitize inputs, avoid logic errors is the main reason. Also, you mentioned something about not using getters and setters in Scala. Yeah, so Scala you can, well, I was saying that before I read your message, but Scala you can add it after the fact. Also, Scala, Python, C#, and a bunch of other languages, you can add them after the fact. I don't know if C++ can do that yet, or if they plan to or whatever. So C++, at least last time I touched it, you would also do getters and setters. But it depends on the language if it has a mechanic to add getters and setters after the fact, using variable assignment notation. And getters, I didn't mention getters yet, but going back to my example of health bars, you might want to change get HP. Maybe you want this to return a double instead of just the straight up HP. You want it to be this max HP, and that's going to be integer division. So I'll have something. One of the quick dirtiest ways to avoid integer division, by the way, is to multiply one of these values. I'll do in parentheses to make sure. Is multiply one of the values by 1.0. That's going to effectively convert it to a double, and then you're avoiding integer division. So maybe sometime down the road we have a meeting and we decide that get HP should return the percentage of their max HP that they have, and we want to return that, and then it just makes it easier to display those health bars. If this returns 0.5, you know to display that health bar is half full. And you can change that in the getter. So the setters, you're sanitizing inputs. With the getters, you're typically doing formatting. If you want to format, if it's a getter for a money value, maybe you want to format it as $ and 2 decimal points. That's where what you would use your getters for. If people are accessing the raw representation of the data, now everybody who's using those values has to do their own formatting. It's a lot easier if you just do the formatting for them in the getter. Okay, and that problem doesn't exist. Let me compile so it goes away. Go away. That's not a problem. Wait, I run it again. This is not a problem. Whatever. All right. Private versus public. Static. So notice when some of my methods are blue and others are gray. Yes. Why aren't any of mine gray, actually, now that you mention it? Some of mine should be gray. I think I have something weird going on here. Do I have to rebuild? Where's all my buttons? Build project. I think think my ID's lagging behind a little bit because this isn't a problem and some of these should be gray. Once I get mine gray, I can talk about it. It's really weird that they're not. Gray means that if you hover over it, it'll tell you, but it means that you didn't use that method. I'm wondering why mine are not doing that, because mine should be as well. Like Battles 1, I never use this, so if I hover over it, is assigned but never accessed. If I never use that variable, it'll be grayed out. That's not an error, like it doesn't affect the way your code runs. It's the IDE giving you a heads up that says, hey, why would you create this method, this get attack power method, but you never called it, so it's graying it out to say, you know what, why did you write this thing? And the answer is, well, it's because this is a lecture example and I'm just showing methods and stuff. But in the real world, in practice, if you have grayed out methods, it's a good reason to, either you're just not done writing the code, but if you're done writing the code and it's grayed out, it's a good reason to just delete that method if you don't think it'll ever be used in the future, at least. But yeah, this is getting in a jammed up state somehow. I mean, everything's fine with it. Maybe if I write a main method in here and run this thing. Yeah, I'm still not getting them grayed out, but that's just an IDE thing. Like, that doesn't affect my code. I did get rid of that related problem that was popping up. But yeah, these, most of these methods I never called, so they should be grayed out. It is peculiar that they're not. Oh well. I ain't gonna worry about it too much. I ain't worried about it. But don't worry if your things are grayed out. Yeah, it's a good tangent though, because I didn't even notice that in mine. So if your code looks different than my code, that's something that you should bring up. But yeah, now I am a little distracted that why aren't. It's just going to be some weird way that the IDE behaves, apparently, but alright, I ain't worried about it. Static versus non-static. So notice that no methods, nowhere in any of this code for my player class does the keyword static show up at all. Like, nowhere is it in here, nowhere. Whereas before today, except for our unit testing, everything was static. I had static on every single method. So let's talk about the difference between static and non-static. What is the actual difference? Because we talked about it before. I kind of briefly mentioned it, but not really. Let's talk about what the difference is between static and non-static. In a sentence, static methods and variables belong to the class in which they're defined, and non-static variables and methods belong to objects of that type. So the player constructor, the get max HP, let's pick on this method, get max HP method. This method is not static, meaning it belongs to objects of that type. So when we create a new object, then we're going to call methods through that object. We're going to do player one, which is a reference to a player object, the dot operator, which takes us to the object itself, and then call get max HP from that object, not from the class. And the big difference with these methods, besides that's class versus object, is that in our non-static methods, we have access to the object that called the method using this keyword this. This will show up in every single is usable in every single non-static method that we write, but it doesn't it's not available in our static methods. There's no this in a static method. Cannot be referenced from static context. So we can't do anything with this because it doesn't make sense in a static method. Static methods basically behave like functions. This is the big difference. I said this with the constructor, but this is the big difference with methods versus functions. Is functions don't have the context from which they were called. Functions are strictly input-output behavior. But methods have this extra context in the keyword this, which is a reference to the object that called that method. So that's the big difference. That's why we say method our in our would-be functions that are within a class, because they have that extra context. Even when they're static, we still call them methods. I don't know why that. But this is the big thing. We have the keyword this that just appears out of nowhere and stores a reference to the object that called that method. Trying to think. I feel like I missed something there. This, static, non-static. I have more to talk about static versus non-static after the memory diagram that's coming up. And let me just make sure, yeah. Make sure I hit what I want to talk about here. And let's set this up for the memory diagram. Let's do the memory diagram, and then we'll have a lot more to say about all those topics. But that's most of the concepts I want to talk about. Actually, let's get one. Since I said I'll forget about toString, let's just talk about it right now so I don't forget. If we print something to the screen, and we print, say, player 1 to the screen, and print one of our own objects to the screen, what we're going to get is probably not what we want. We're going to get this garbage. What we're going to get is the fully qualified name of that object. That's the entire package and class name, the @ symbol, and then some random to us hex value, which is somewhat semi-related to the reference of where to find this object, but it's obfuscated through the JVM. It's just some random value to us. It does identify the object, but not in a really meaningful way. And this is pretty much always not what we want. We don't really want this to be printed to the screen when we print one of our objects. But what do we want to be printed? So we can change this behavior by writing another special method, just like the main method in the constructor. If we write a method with a very specific signature, it's going to be treated in a specific way by Java. And this one is what we call a toString method. So we're going to write a method that returns a string and is called toString with a capital S and take no parameters. And I typed it wrong, so that wouldn't have worked. But it takes no parameters and returns the string that you want to be printed to the screen when you print your method. So if we return, let's say, HP equals this dot HP plus a slash plus this dot max HP, this dot name, as, let's do it like that. So we want to do a little bit of formatting and print their HP to the screen with their name. And now it'll print exactly that, their name, and then what their HP is out of their total HP. So whatever string we want to be printed to the screen, we can write a toString method and have that replace that default garbage behavior with something more meaningful to us. This can be really helpful in debugging if you write a toString method so you can just kind of see what's going on, or preferably run the actual debugger. I prefer running the debugger personally. Run the debugger and then you have access to all the information without having to write a toString or anything. But the toString can still be useful for other reasons down the road too. You want to display something to the user using a toString method, you have that option available to you. All right, now let's set up, because I don't want to trace this because there's a lot going on there. So let's set up a little bit simpler example to trace. I do want my two objects being created. I'm going to have a third one, player 3 equals player 1, player 1 dot set. I'll stick with the example I have in the slides. Paladin Cecil. So Cecil's going to change his class to Paladin. And we're going to print out player3 dot get name. Oops. get name. I'll leave the rest of it. Oh no, I have the rest of it in the other class. It's fine. And let's head over to a memory diagram. Let's trash can this that we're going to see later, at least in some form. It'll be different because it depends on what I end up writing. Okay, did that, we did that. Oh, I skipped one thing. We didn't call these methods. We didn't call these methods. We did call get name and set name. There we go. And then we can get everything on the screen. Okay. I do want to change one thing here. So when we have, especially when we have our sanitation like this, let's grab this method. I guess I could have just not deleted it. Let's grab this method, and then right here call our setter set HP. So when you have sanitation like this especially, it can be useful to call your setters from your constructor instead of doing direct variable assignment like this. If you call your setter, you're reusing all this sanitation code because you want to sanitize your inputs for your constructor as well, not just for your setters. And this comes up in task 2 when you're sanitizing your ratings. Ratings have to be from 1 to 5. If they're outside of that range, they're an invalid rating. So you want to do that sanitation twice in the constructor and in the setter, but you don't want to have to write the code twice. If you write the code twice and you have a bug and you have to fix that bug, it's an extremely common mistake for developers to make, for all of us to make, is you fix the code once and you forget that you have duplicate code and you don't fix it in the other place. So you have a setter that's working but a constructor that's not. We don't want to do that. Whenever you have duplicate code, that's a strong indicator that you need to do something better. Reuse the code that you wrote. Everything you learned about functions in 115, you're reusing that code. Let's reuse this code and call the setter from the constructor so we're sanitizing the HP in both places. Now in this specific example, that doesn't really matter because HP is being set to max HP. It's not going to exceed it if it's exactly it. But the point remains for your task 2 that for the constructor, I will test that in Autolab. I'll give your constructor invalid ratings and I will give your set rating method invalid ratings. Take advantage of that code that you write one time by calling your setter in your constructor. Okay, and save you some time and headaches. All right, so let's trace this thing. Main method. Every Java program starts with a main method, and it does get a little trippier once we have a lot of code in a class, and the main method by convention is going to be on the bottom, going to be the last thing in your class. So the main method, you should always look for it on the bottom. This is pretty consistent across all developers that the main method will be the last thing. Oh, I'm covering up some code. I wonder if I was covering it up in 8 a.m. and didn't notice. Oops. The main method will be the last thing, but every Java program will start with a main method. So scanning through all the code till you find the main method and then run that, which can be a little trippy at first because we're used to, starting at the top. Every book you've ever read or anything, you start at the top and go down. But here we got to look at the bottom and then jump all around this code based on where the code tells us to go. So it's one thing to get used to if you're not already. So player 1, and oh boy, we got our first constructor call that we actually trace. So we called ArrayList and HashMap constructors, but we didn't trace them. Any code that's internal to Java, we don't bother tracing, so we just didn't trace it. But now we have to trace our first constructor, and there's quite a bit that goes on when we have a constructor call. So first, we have our variable that we're used to, and then we do have a method call. So we have new. New is our indicator that we're going to create a new object on the heap. And this is your cheat sheet for doing your traces, especially your OOP traces. It comes up in the data structures trace as well. When you see the keyword new, you will create a new object on the heap. That's what the keyword new does. It says, hey, Java, we're creating a new object on the heap. Let's go do this thing. So that's what's happening in the code. So in your trace, you have to remember, you see the keyword new, you should click this create heap object button, because that's exactly what the keyword new does. When we create a new object, just like array list and hash map, we're going to put the type of the object right here. So this is an object of type player. And this is a method call. When we call a constructor, this is strictly, I mean, the keyword new says new object, but the rest of this is a straight up method call. We're calling a method called player and giving it 2 arguments, Dark Knight Cecil and 10. And we're calling this method. Now the method happens to have to match the name of the class, but that's, so this will be the class name. It looks like we're messing with the class itself, but really we are just calling a method. This is a regular kind of a regular method call, so we're going to do our regular method call stuff with it. So let's put the method on the stack. The one big difference here is that every static method has access to this special, or every non-static method has access to the special keyword this, and we will trace that. We do trace that. So the first thing that goes in every non-static stack frame is going to be the keyword this, that stores a reference to the object that called that method, and in the case of constructors, it is the object that is being constructed, which also is technically the object that called that method, but in a weird way. So this is CSE116, a reference to the object that's being created. Then we'll map the constructor, this constructor dropdown with array list and hash map. We didn't trace the constructor call, so there's nothing to do here. But now that we're going to map the constructor, which is going to give us some nice color coding with all our references and the object and everything. It makes your trace a lot easier to read if we map the constructors. And then the object itself, we used to use name and value for index and value or key and value, but they've always been called name and value. That's because the usual use case for these are for instance variables, just like we have variables on the stack with the name of the variable or keyword in that case, the case of this, and then the value that that variable is storing. These are the instance variables. So when we create a player, that player gets copies of all 3 of these variables on the heap. So in the heap, this object is going to have max HP, and name as 3 different variables, which are not being initialized to anything, so I'm going to leave their values blank for now. They are technically initialized to initial values, like the initial value for an int is 0. Technically, this gets the value 0, and then it's overridden. If you want to trace it like that, that's fine. That's more accurate than the way I'm going to do it here, but that's definitely not a requirement of the course. Because then you have to memorize every initial value for every type in Java, and we're not doing that. There's no reason to do that. I mean, most of them are what you would expect them to be. 0, empty string. Actually, I don't even remember what the default for Boolean is. I would guess false, but I mean, I guess I got a 50-50 chance of being right. And then at that point, so we create the object, map the type, create the constructor, map the constructor to the object, create the instance variables, and put this as a reference to the object that's being created. A lot of things you got to remember for a constructor call, and all those things will be on the OOP quiz. We have to make sure all that stuff is down. You got all that down. So there's a little bit of memorization. We try to limit the memorization in computer science, but that's one, you have to just know everything that happens when a constructor is called. And those are the things that happen. Once you have those things, the rest of this is a method call, like most method calls you've ever seen. We have 2 parameters, name, which gets the value Dark Knight Cecil. So I'm going to cut and paste so I don't have to keep typing that. And max HP, that gets the value 10. Now, do not make the mistake. I'll say this a bunch of times because it's a very common mistake, but do not make the mistake of making up parameters. A lot of students, and I have speculations, but I don't know for sure why so many students do this, but there's no name, max HP, and implicitly this always exists in every non-static method call. And that's all we have here. There is no variable HP on the stack. There's no parameter, there's no local variable called HP, but so many students will put HP on the stack here because it's an instance variable. They just think every instance variable automatically goes in the stack. It does not. And this is one case where, again, I recommend kind of turn your brain off a little bit when you do these traces and just go line by line and do exactly what the code tells you and only what the code tells you. And the code does not tell me to put any variable named HP on the stack in any stack frames. It tells me to put HP in the heap, in this object on the heap, but it doesn't show up in the method call, which means it doesn't exist. It doesn't happen. But if I gave this as a quiz, so many students across all semesters will put HP in the stack, which is wrong. That is wrong. Usually that's a minor mistake and won't cause you to fail the class, but it is absolutely wrong. Sometimes they'll do that and then that causes them to make a major mistake down the road, so it can lead to a major mistake, but it's always wrong. So once we have this and the parameters, then we go through the code and we see our first dot operator using the keyword this. So this treated just like a variable, and when we're tracing the keyword this in the stack, it's a lot easier to see what's happening with this. We have this that stores the reference OX100. We're going to use the dot operator, which says everything to my left is a reference that resolves to a reference. Take me to your object. So this dot is going to take us to this object right here, and then we're going to look for something called max HP. We find it right here as an instance variable, and we're going to assign that variable to some value. Then we're looking at the right-hand side of the equal sign, max HP. This is a new expression, so we start over at the stack frame again. It's very important to know every time you're evaluating a new expression, you start over at the stack frame. So max HP from the stack frame is going to be 10. Don't make the mistake of saying, oh, this dot, we were at the object, so we're still at the object, so max HP equals max HP, which is uninitialized, so it's being assigned an uninitialized value. Maybe you realize, oh, the default value is 0, so it's being reassigned to 0 and already was 0. Don't make that mistake. We start over at the stack frame, and we get this max HP, which is 10, and then assign it here. And then next line, this dot set HP. This dot set HP, we're calling a non-static method. So we know set HP is going on the stack as a stack frame. And every single non-static method call, which is going to be pretty much every method call from here on out, we're not going to see the keyword static very much moving forward from this point in this semester. And I don't, aside from main methods, of course, main methods have to be static. But other than that, I don't think the keyword static shows up outside of a main method in any of the quizzes, any traces. You're always tracing non-static methods, which after today, non-static methods, I'm just going to call them methods, including on homework descriptions. If I just say write a method, I mean a non-static method. If it's static, I'll explicitly say write a static method, which does come up in task 6. There will be some non-static, some static methods that you'll write. But other than that, most of them are just going to be non-static from this point forward. So every non-static method call has this, and I just get in the habit of, if I create a stack frame, I'm going to put this as the first thing in that stack frame, which is actually hard for me to do in the first few lectures where we don't have the keyword this, kind of have to resist my urge to put the keyword this in my stack frames because we only have static methods at that point. So I got to resist the urge to put this, but now I create a stack frame, I'm putting this immediately. So this is a reference to the object that called the method. We called it from the player constructor, this dot. So this is the object that called the method. So this is a reference to that object OX100. We have one parameter, HP. It gets the value max HP from the player constructor. That's a new expression, so it's evaluated from the stack frame, which is 10, not from the player object. We're not looking at this variable, or this. This one we could actually mess up. I mean, they're both 10, but it's not this variable here because we're not at the object at that point. We're at the stack frame, and we find this max HP here. They are both 10 in this instance, but it's important to know how to get the right one. So when they are different values, you make sure you're getting the right one. And then set HP. We're going to go through this logic. HP greater than this dot max HP. This dot max HP is 10, so this is false. So we get this dot HP equals HP. This dot HP equals HP from the stack frame. That's 10. And this returns. We get to the next line. This dot name equals name. This dot name equals name. And then the constructor returns. When a constructor returns, this whole thing, new and then constructor call, resolves to a reference to the object that was created, which in our case is OX100. It's always whatever this is in the stack frame for the constructor. So that's what's returned here, and player 1 gets OX100. So that's our first constructor call. First of very, very many. We're going to see many constructor calls, including right now. We're going to see our second one. I'm going to get Dragoon Kane in my clipboard. I should have just grabbed the quotes too. Whatever. So let's review what we do for a constructor call. First, our variable that was true all of 115. Our variable, we're going to create in the order. Sometimes I'll do these in different orders, just the order I think of everything. But we're creating a stack frame for the method call, which I'm in the habit of always putting this right away. Even if I don't know the value yet, but I know it's a non-static method call, it's going to have the keyword this is the first thing in the stack frame. If I put it there right away, I won't forget. I'm going to create an object of type player. New tells me that I'm creating a new object. The constructor, it's going to be this red constructor here, and it gets copies of its 3 instance variables, max, HP, and this is the order I like to do it in. I'll set up the frame, but then I'll do the object, all the object stuff, so I don't forget to add all my instance variables. Name, max HP, HP, and name. So any variable that appears outside of the methods, those all are instance variables, and we get a copy of them every time we create an object. So these 2 player objects each have their own copies of all 3 of the instance variables, and those variables can have different values. And then this, the object we're creating, got OX200. The constructor takes 2 parameters, name and max HP. Name is Dragoon Kane, and max HP is 14 for Kane. Then we run the constructor. This dot max HP equals max HP. This dot max HP equals max HP 14. This dot set HP. So we have set HP called from OX200. So this is OX200. That has one parameter, which is HP, which gets the value of max HP from the previous stack frame, 14. And it does if HP greater than this dot max HP, if HP 14 greater than this dot max HP 14, that's false. So we go into the else, There's no variables declared in this code block, so I'm not putting my code block in the trace. We can have an empty code block. That's fine if you want to do that, just to keep track of everything and make sure you know there's a code block. But it's not required if there's no variables inside of it. There's no variables declared in it. So this dot HP equals HP 14. This returns, and then this dot name equals name. This dot name equals name Dragoon Cane. This returns and resolves to a reference to the object that was just created. OX200 is what's stored in player 2. Oh, excuse me. Okay, so those are our first two constructor calls we're tracing. The constructor is a non-static method, so the keyword this appears in all non-static methods. Other than that, the constructor is a regular method call. Parameters, local variables, if there are any, and its purpose is usually to initialize the instance variables. But when you're tracing, you're not worried about purpose. You're just tracing the code line by line, going kind of blindly through it. Creating an object gets copies of all of the instance variables defined in that class. Map the constructor and put the type. Well, the type, you did that for list and dictionary in 1.15, and array list and hash map in 1.16 so far, so that's nothing new. But it's the type of the object, which is the name of the class for that object. So those are all the things we need to remember, and then the constructor resolves to a reference to the object that was created. That's the same with our data structures as well, so nothing new with that part either. But tracing it, getting your instance variables on the heap, a few new things here. Okay. And then player 3 equals player 1. What an important line right here. This is crucial to know. If you mess up on this line, that is an easy instant fail on the quiz. And I'm going to mention a couple of those. I think I'll mention them all right here. We have player 3 equals player 1. This is the same thing as when we did this with data structures, but it's so important. We're going to talk about it again right here, but a little briefer at this point, because you've seen this so many times already. But player 3 equals player 1. So player 3 gets the value of player 1. The value of player 1, I mean the name player 1, has the value OX100. OX100. Done. That's all that happens on this line. Do not make the mistake of thinking that a third object is created. When we read this code, we like to think of this as a 3-player game. We have 3 players, player 1, player 2, player 3. Well, we don't have 3 players. We only have 2 players, and player 3 stores the same reference as player 1. So player 1 and player 3 both refer to this same object, this Dark Knight Cecil object at OX100. There's no third player that's being created. And again, your cheat sheet for this is the keyword new. When I'm done with a trace like this, when we get all the way to the end, is if I'm submitting something for a grade like this, what I'm going to do to double check myself is look at how many times the keyword new was used in that code. When I see the keyword new, I know that I'm creating a new object on the heap. That's what the keyword new does. It says we're creating a new object on the heap. And the opposite is also true. When I don't see the keyword new, I am not creating an object on the heap. So on this line, I don't see the keyword new. That means no new object was created. So my double check is go through the code. After I'm all done tracing, I do one quick scan. I look at how many times the keyword new was hit in the execution of the code. So new was hit twice here. And I have to check, make sure my method calls didn't use the keyword new. And the keyword new doesn't show up anywhere else, so I know none of my method calls are using the keyword new. So we have 1, 2, and that's it. 2 times the keyword new was hit in this code, so I better have exactly 2 objects on the heap when I'm all done tracing this code. And I have my 2 objects that matches the number of times the keyword new was hit. I'm feeling good about that. I passed my check, and as long as everything else looks good, I'm ready to submit. If those numbers don't match, it is an instant, obvious fail. It's a really easy one to grade for us, for myself and the TAs. If those numbers don't match, if you have a third object on this heap, if you have player 3 OX300 pointing to a third object on the heap, very obvious that you did not complete the learning objective that's being assessed. You don't understand references, objects, constructors. Somewhere in there, you do not know what's going on. Very easy to say you did not complete this learning objective. Study some more and try again on the final exam. Don't be in that position. Make sure you're only putting objects on the heap, only creating new objects when you see the keyword new. Player 3 equals player 1. I can guarantee this will show up on every OOP quiz. You're going to get something like this where we have an assignment by reference, and you need to know that a new object wasn't created during that process, that there was no constructor call. Very important, absolutely a learning objective. So I keep saying a lot of things like, oh, minor mistakes. If I forgot what one I just mentioned. If you put HP in your constructors, like, yeah, you don't fully understand constructors at that point, but not to the degree where you didn't complete the learning objective if you got everything else correct. But if you have a third object on the heap, like, you do not understand what's going on here. Not to the level where I'm comfortable throwing you into 220, because you're just going to fail 220 if you have 3 objects on the heap in this example. So that's an easy way to fail because you clearly didn't complete the learning objective at that point, and you got to study more. You just got to study more at that point. But that's pretty rare these days. Since I started giving these speeches in lecture, I see that mistake very rarely now. So don't get complicit. Make sure you're paying attention to it. But I'm a little less concerned than I used to be about that. It used to be like half the class would fail the first quiz that assessed that because they had 3 objects on the heap. Okay, moving on. Player 1.setName. Player 1 dot means take me to your object, and then we call the setName method from this object right here. So we have setName. This is going to be OX100, the object that called that method. And setName takes one parameter called name, which is going to get the value Paladin Cecil. Which I'm going to do clipboard. And then this dot name equals name. This dot name equals name. So we're going to cross out the old value just like our variables on the stack. Variables on the heap, if we update their values, cross out the old value, write in the new value, and this method call ends. And then we do player3.getName. Player3.getName, we're calling getName from this object right here. So getName, my mic's in the way here, so I can't really see what I'm doing down there. GetName, this is OX100. That's going to return this dot name. This dot name is Paladin Cecil. That's what this returns, and that's what's printed to the screen without the quotes. So if you're, and I think this is pretty clear when we see the memory diagram, but if you don't see the memory diagram, when you're just looking at the code, this is an easy mistake to make, to miss what's happening here. Because player 1, player 2, player 3, our brains want to think of those as 3 different objects when they're not. And when we change player 1's name, we'd be tempted to say, well, player 3 is a different player. You know, player 3 is going to be Dark Knight Cecil. But once player 1's name changed, it's not player 1's name that's changing. It's the object referred to by the reference that's stored in player 1 that's changing. So we did player 1 dot, went over to this object and made the change. And then player 3 dot follow the same reference. These 2 variables store references to the same object on the heap. So player 3 dot get name is getting Paladin Cecil, not Dark Knight Cecil, because that's what's stored here on the heap. So a few things here. two variables can refer to the same object, and changes made through one variable will be seen through the other variable. We made a change using player 1, but player 3, that variable still sees that change because it was made on the heap. And also, we have void methods. We are starting to make use of void methods, and we will continue to use void methods quite heavily throughout the semester. And the first time you saw a void method, I had that method called why, and I said, why would we ever do this? You should probably have been wondering why, literally, why would we ever use the keyword void? That doesn't make sense. Why would we write a method that doesn't return anything except the main method? There's nothing to return back to the caller. That one makes sense. But the rest of them, why would we ever write these methods? And this is why. We call void methods for their side effects. And more often than not, most cases, the side effect is going over to the heap and making changes on the heap. So if we make a change on the heap, that change will be seen after that stack frame ends. Because everything in the stack frame is gone when the method ends, and we didn't return anything, so it seems like the stack frame was useless. It didn't do anything, but it had the side effect of going to the heap and making a change. I should point to the right one. Set name went over to the heap and made a change to an instance variable of an object, and that change outlives the stack frame. Even though the stack frame didn't return anything, it did have an effect on the behavior of our program. Just like when you have an array list, you call .add. You're not calling .add for its return value. You're calling .add so it can go over to the heap and add a value to that array list object on the heap. So we're going to start writing methods that do that return void, including every setter, but we'll have more complex methods too. They'll return void, but we will call them for specific purposes to have the side effect of changing values on the heap. And then we reach the end of our main method, cross out main. Oh, now I moved my mic and I can't see the clock. 12:31. In 1 hour, the timing of these lectures is kind of strange because we just got through the first portion. We have like 2 more lectures of content, but I have this all mixed up. I think Monday every semester rolls over into most of Wednesday, and then I just got to reorganize how much I cover in each lecture. But don't fret, I'm not concerned. We're gonna get everything we need out there. Okay, so let's go back to the code, and we're actually gonna look at some. Let me just double check. I'm too paranoid that I forgot something. Oh, yeah, there's one thing. And once we, a couple things. Just a couple of small things, nothing that you can, a lot of this could be inferred, nothing that you couldn't live without, but let me make sure I make them explicit, because I make them explicit in my slides, is once we define a new class like this, what we actually did was create a new type in Java. So Java, we've been talking about types all semester for the whole 2 weeks of the semester. We've been talking about it all semester about types, and we had array list and hash map and int and string. What we're doing when we create a new class is we're creating a brand new type in Java. So if we're not satisfied with the types that Java provides for us, we can create our own. When we want to create a player type that has these 3 variables, we can do that and then give it its state and all of its behavior, all of its instance variables and all of its methods. We can define exactly what this type does. And then once we do, we can use that type anywhere in our code. And we saw that right here. We used that type as a variable type. We have a variable of type player. That's a type that we created. And we can create variables of that type. And we can also use this type anywhere where we could use any other type except our primitives. Primitives are a special case always. But we can use these in anywhere we can use any types. We can have methods that return that type. This is going to be an error because I'm not returning anything. We can have methods that take that type as a parameter. Parameters are just variables, so that's perfectly allowed. And we can also have oops, I set this up to do it down here, but we can also use that type as type parameters. So we can create an array list of type player. This is perfectly valid code. We can have an array list of players because this new type can be used wherever we used any other class type before. We can use our new type. So we defined a brand new type in Java. And when we do that, and let me go back to the trace for this one. Oh, I never full screened that trace. I did the whole thing out of full screen. And when we're tracing our code, our primitive values, all these ints that we have, the ints, lowercase d, doubles, our primitive values, any value that starts with a lowercase letter, is stored directly by value in its variables. So this variable HP stores the value 10 as an int. An int in Python is a 32-bit value with 1 bit for the sign and 31 bits in binary for the value. Those 32 bits are stored directly in this variable HP, including any variables on the heap. Max HP stores 32 bits that represent the value 10. Max HP here. These are directly values that are stored in the variables. Everything else in Java is stored by reference. So everything else will be by reference, including the player objects that we created of our own types. Every class you make and you start creating objects of that type, they will all be stored by reference. Your data structures, array lists, and hash map, you're used to that already. Everything else also is going to be stored by reference. Everything else. You've already seen all the things that are going to be stored by value. Those are ints, doubles, booleans, and strings are weird, but we pretend strings are stored by values. This name variable actually does refer to another object on the heap. We're going to keep things simple in 116 and pretend that it doesn't. Capital I integer, capital D double, capital B boolean, those do technically refer to objects on the heap as well. We're going to ignore it and pretend that they don't, or else things get way crazy. You have an array list of integer, and each index refers to an object on the heap. Like, it'd just be a pain, and for no actual gain either. You wouldn't learn more about the 116 learning objectives by doing that. When you get to 220, that'd be more of a 220 thing, how exactly everything is laid out in memory. 220 will care more about those types of things. 116, OOP and data structures and testing, those are our primary learning objectives. So we're going to gloss over some details there. Right. Yeah, and then this Wednesday, I gotta reorganize this week. During the regular semester, it's kind of awkward. When it's all one lecture like this, it ain't too bad. But during the other semesters, it's just way imbalanced. So this Wednesday lecture is really light, and we'll be on the Friday lecture pretty quick. So with that, what I want to do now is talk about the ArrayList class. And what we're going to actually do is go into the source code for ArrayList. So now that we know how to create our own class, we know how to write our own constructor, create our own type, so we can create objects of that type, have our methods and instance variables and everything. Well, we've seen the other side, the user side of that, how to use the ArrayList class and the hashmap class, and now we've seen the side where we can write our own classes like that. So let's crack open the ArrayList, because now that we know, hey, the ArrayList has to do all that stuff too, right? Like, yeah, it does. It absolutely does. So let's go to the ArrayList class and see how it does it. So whenever you have like ArrayList here, or anything, you can hold Control and click, or on a Mac Command and click on something to take you to its definition. So if I want to go to this player constructor definition, I'll hold Control and click on it, and it'll take me to that method definition, even if I'm in a different class. From over here, I have get max HP, and I want to see the code for that. I can Control click it, and it'll take me right to it. Very handy thing to do in IntelliJ. Very handy to navigate code. I use this all the time. I want the definition of this instance variable, take me right to it. I don't have to scroll up and down and look for things. I just control click all the time. So we can do the same thing with array lists. Take me to the array list constructor, baby. And we're going to go for it. In the slides, I trim this way down and just show little pieces of the array list class. Since we're doing this live coding style, we are going to see a lot more stuff. You know, I'll just tell you to ignore it. Like all this stuff, we can ignore it. You ain't got to worry about it. But it will be there on screen. So let's take this right from the literal top. And when we import the ArrayList class, we say import java.util.ArrayList. So we do know, and I think I showed this in both lectures before, is the package has to be java.util, because we know that, because that's how we imported it. And the class name has to be ArrayList. So class ArrayList, we can see that that is, that's matching what we expect. And this is in a file that's in the directory util. I'm not going to scroll all the way up, but we're in a directory. I'm blanking on now. We're in a directory Java in a subdirectory util in a file called ArrayList.java. So everything matches up with what we talked about on day one with that. And there's a lot of extra stuff here. We're not going to worry about any of this. Not today. By the end of the semester, you will know what all this stuff means. Not necessarily these interfaces and this specific abstract class, but you will know what abstract classes, interface, extends, implements, and this bracket E. Bracket E, that we'll actually learn next Tuesday when we do linked lists. Today, we're not worried about it. But we are creating a class called ArrayList, and we know that a class is a collection of state and behavior, where the state is all the instance variables and the behavior is a collection of all the methods. And we can see that we have, I'll circle back to these static variables in a minute. We will talk about those. But and I didn't realize this had the keyword transient here, is the instance variables. The non-static variables, these are going to be the instance variables that exist in all of your, can I just change this to private? I don't even remember fully how transient works. Pretend that says private for me, please. So we have non-private to simplify nested class access. So that's why it's transient, so nested classes can access it. That wasn't always like that though, right? I took the code from, I wonder if that was actually a recent change, or maybe I just changed it for the slides instead of... Anyway, I'm getting distracted. So we have two non-static variables. These are going to be the instance variables that belong to every ArrayList object that we have. Now, ArrayList is a data structure that has a lot of nice user features that make it easy to work with the underlying data. But the underlying data is actually a plain old array, which we won't mess with in 116, but it's an array indexed at 0. And the important thing about arrays is that they have pretty much no functionality. You can ask it for its size, and that's about it. In C, you can't even ask an array for its size, if that's still true. I would assume that's still true. But in Java, you can ask it for its size, and that's about it. And you can access indices, and you can modify indices, values at specific indices. What you can't do is change the size of an array. It's one real big shortcoming of using an array, and we don't like that. We like to be able to change the size of our data structures. I want to call ArrayList.add and just add stuff to my array list after I create it. If I create an empty array list, I don't want it to have to be empty forever. That's not super useful. I mean, it is, but it's just tougher to work with. The empty one isn't useful, but not being able to change the size is pretty limited. But a regular array, you can't change the size of. So we use the ArrayList class, which does use an underlying array to get the job done. We can see that here is because that's its instance variable, but it's going to let us pretend that that array can change size, even though it actually can't. and a separate int that controls that stores the number of values that are in this array list, which is not always, and most of the time it won't, be equal to the size of this array. Usually this array is going to be larger than it needs to be, so we would need to separately track the number of values that are in the array list. Then we have, I'm not talking about this one at all. Can I just collapse it? And then this, our first constructor, we have a public constructor for the array list. And by the way, I have a slide for this, but I'll just mention it here. Oh no, actually I want to mention it later. Sorry. That we have the constructor that takes no arguments. This is the first one that we saw for array list. And it's going to create just an empty, straight up empty array list. And it's going to initialize that element data instance variable, that underlying array, to a default empty array, which is a static, private static final instance variable. And I skipped the epsilon stuff when we did comparing doubles in this lecture, so let me spend a little time talking about this. Final means that this variable cannot change. You cannot reassign this to a new value ever. It's a constant. So since it's a constant, by naming conventions, we like to spell it in all capital letters. Then it's very clear to anybody reading the code that this is a constant. If they're way down here, they know that this is a constant because it's all capital letters. So it's a nice convention thing that helps us communicate to other devs and ourselves reading this code in the future that this is a constant. It's not going to be able to change. And it's an array that's empty, and that's what our initial value for element data is if we call that constructor, that first constructor. This is a static variable, meaning it belongs to the class itself. So we have quite a few static variables here, and these are going to belong to the array list class. So we're accessing them through the class. Static belongs to the class. You would do problem set dot average. Average is a static method. It belongs to the problem set class itself. So when we access a static variable or method, it's the same, and I can't type here, but it's the same as saying array list dot default capacity empty element data. That would do the same exact thing if I added that here. I can't literally do it, but it would be the same exact behavior if I had array list dot right here, because that static variable is accessed through the class. We don't do ArrayList dot here, and Java will still find that variable if the variable exists in the as a local variable in the stack frame. That's where it'll search first for a variable when it has to resolve a variable. If it doesn't find it, I actually didn't mention this before. All right, side note, we gotta go back to the last example just briefly here. If I do like right here, I'll get no, I won't get away with it there. Oh shoot, I don't have it set up to do this. Right here actually. If I do max HP right here without doing this dot, so I do want to go to the instance variable for max HP. If I just do max HP, what Java will do to resolve a variable when you just use a variable name like this is it will look in the stack frame for a variable with that name. So max HP, it's going to look, there's no parameter named max HP, no local variables named max HP. So it's going to continue its search by following the reference this. It's going to follow that to its object and look in its instance variables, and it'll find the instance variable max HP and use that one. If it doesn't find it as an instance variable, it'll continue to the class's static variables and look for the variable there. If it doesn't find the variable there, it'll give you an error and give up. So if I don't use this dot, I like to put this dot everywhere just to make it very clear that I'm using an instance variable. But if you don't, I'm in the wrong class. Man, what the hell am I doing? But if you don't use this dot, it is sometimes optional, but not always, because for example, with HP, I'm doing this dot HP. Follow the reference this to its object and look for the HP instance variable. That's what this code is saying. If I just do HP, I'm saying look for a variable HP, and if it doesn't find it in the stack frame, it will find that instance variable, but in this case, it will find it in the stack frame, use the parameter HP, and then we're not going to get the behavior that we want to get. With max HP, we don't have a parameter named max HP. We don't have a local variable named it. It doesn't exist in the stack frame at all. So we will get the instance variable. But with HP, it'll find the local variable instead. So here we actually have to do this dot or rename our parameter. But with max HP, we can get away without using it. But for my examples, I always like to put this dot. But when I'm in the ArrayList class, they're not going to do that. They're not going to do ArrayList dot, which I would put right here just to make it explicit of what I'm doing. But they will get, okay, this doesn't exist in the stack frame, it doesn't exist in the instance variables, but it does exist in the class variables, so it's going to use that class variable. Whew. All right, and we do know that ArrayList, and I'm actually going to collapse this too so we don't get, actually, nah, whatever. But we do have a second constructor when we did new ArrayList, arrays.asList, and then gave it comma separated values. We don't have to get bogged down on the details of what's happening, but just what I want to highlight is that there is a second constructor that takes a data structure and initializes the array list. It'll go through all the values in that data structure we gave it and add it to that underlying element data instance variable. So it'll take everything in this data structure and add it to the array list that you're creating, which is what you would expect it to do, except it is, the code is more unreadable than you probably would expect, I guess. But the effect is what you would expect it to be. And this is what's called an overloaded constructor. In fact, we can have this with any method. We have two constructors with the same name. Actually, there are three, but I don't want to talk about the other one. And they all have the same name. This is allowed. You can absolutely have multiple methods with the same name as long as they have different parameter lists. And here their parameter lists are different. So if you call the ArrayList constructor and don't give it any arguments, you're going to get this constructor. If you give it a collection with using arrays.asList, you're going to get this constructor. So we get different method calls based on the parameter list. And if we call the ArrayList constructor and give it an int, we'll get this one for what it's worth. But I don't want to talk about that one. I'm going to do my best to avoid it. Let me scroll away from it so I don't get sucked in and tempted to talk about it. And then we have the methods that we've been using all semester. We have the size method. So public, notably not static, returns an int. It's named size, and it returns size. Java doesn't like to do this dot, but I would put this dot size here. It returns the size instance variable. And this is why it's so important to have the keyword, well, not the literal keyword because it's omitted here, but non-static method stack frames have access to the object that called the method. That's how we get the behavior that we expect from our methods. If you have code where you're creating 3 different array lists and storing them in 3 different variables and then storing all kinds of different information in these 3 array lists, and you ask one of them for its size, you want the size of that specific array list. So we need a non-static method that knows the context of the object that called it, so it can have access to the instance variables of that object. So this, we're accessing this dot size, the variable of the calling object, the array list that you called that method from, because you want the size of that specific array list, not just an array list. If this were a static method, you wouldn't be able to get that behavior without some extra work, I guess. But you wouldn't get that behavior in this way because that method wouldn't have access to the object, to any specific object. It would be at the class level, at the ArrayList class, and you wouldn't know what size you're getting. So that's why it's important to have the keyword this, to have a reference to the object, not literally the keyword this because it's not in this specific example, but that's why it's important for non-static methods to have a reference to the object that called them, which in our traces we map using the keyword this, and in our code, yeah, sometimes the keyword this is optional. But it's important to have. And notice that this is public. Just hang on to that thought for the next conversation. The method get, this is the next one that we called. Get is going to take an index and return the value at that index. We'll talk about E, that will actually come up next lecture, like I said. Add is the next one I want to talk about, though. Add, we actually have two add methods, just like the constructor. The add method is overloaded. Oh, there's three. Actually, we do use this one, too, in the course. Let's ignore it for now, because, just keeping an eye on the time. We got to get moving. This is the method we call. This is public, and this one's private. It takes 3 parameters. This one takes 1 parameter, and this is the one we like to call. We call this one where we add one specific value and then let the code do the rest of it and take care of the rest. What this actually does is calls the overloaded add method with some extra parameters, which are the instance variables, and then goes through and does some extra stuff. It calls this grow method if needed, if the underlying array is filled up. What it's actually doing is, if the underlying array is filled up, we can't add to that array. It's not possible. So what it does is actually creates a new array of double the size, copies all the values from the first array over to the second one, and then lets the first one get garbage collected and uses the next one of double the size. So if it runs out of space, it creates a new underlying array. That's how it gives you the illusion of being able to grow, is through that method. But it does some extra stuff here. And this is private. So we can't actually call this method, but it is used when we call the add method. This is a concept called encapsulation. And this is very important. This is our next big use of the keyword private, because the temptation is just make everything public. Why would you hide anything? Encapsulation is exactly the concept of hiding the details, because you don't want people to have to care, and you probably don't care, that the ArrayList add method that we call actually calls an overloaded add method with 3 extra parameters. You probably don't care about that. And the Java developers communicate that by making this private and saying, look, this is how we get the job done, but look, just call the public methods. We're going to give you these 2 public methods. Yeah, they both call the... Oh, of course, this one's not going to call it. Son of a bitch. But yeah, that's why I shouldn't have even focused. I said I wasn't going to talk about that one. I shouldn't have. And you don't have to care that when you call this method, it calls an overloaded method and has this grow method. You don't have to care about the details. You just care that this method does what you expect it to do. And it does its job, and it does it well. Who cares about the rest? So encapsulation means hide the details of how you actually get the job done, but do expose the public interface. Anything that the end user should be able to access, make that public. So we call this method, and the Java developers who wrote this code, they want this other method to be able to actually get the job done, but who cares? Just make this one public and this one private. Just like you don't have to care, going way back to the top here, you don't have to care about all these static variables. Make all those private, because we don't care. We don't care about the details. Encapsulate them. Everything that's public are the constructors that we called, the get, the add, size, those methods that we've been calling all along. Those ones are all public because those we care about. But any details, encapsulate them, hide the details. That's another reason we like this keyword private. And then like your IDE, when you type your variable name and do dot, it gives you the list of everything available to you. It's not going to give you any of the private methods because you can't call them anyway. So it's a nice way to reduce the clutter in our IDE as well. It's just a nice thing to have things that don't need to be accessed by other people, make them private. It keeps everything cleaner. Yeah, that's keyword this, encapsulation, public versus private, static. Yay, we got them all. I don't think I missed a single one there. Go me. All right, and that's the ArrayList class. I'm done talking about that one. And let's just do math.abs of -6 so it actually does something. So let's take a look at the math class too. I just needed some code so I can control click, so I'm not scrolling through trying to find the damn math class. But let's look at the math class too, because this one, same idea, same things that we've been talking about, but approaches things a bit different with those ideas. So the math class, it's a class called math. We should expect that. And it's going to have a collection of a whole bunch of stuff for us. One, the ABS method we just saw, the POW method. And notice that we're calling ABS through the math class, so we know that ABS is going to be a static method. In fact, we can go right to the ABS method. It's going to be a public method because we were able to call it. It's going to be static because we called it through the math class itself. We didn't have to say new math and then call it through our object. We call it through the math class itself. Just like we do problem set.average, we do math.abs. Those are static methods that we're calling. When we call an array list size, we have to do new array list, get an object of that type, and then through a reference, we use the dot operator and then call size on that array list object. But static, we call it through the class. Static belongs to the class. Non-static belongs to objects of that type. So we expect this to be a static method. And I gotta get back to the top here. And the math class also has, you can look through the math class. By the way, if you ever want to know like what's available, what can I call in the math class? The definitive answer is go to the source code, control click on math, and just scroll through and look at all the stuff that's in here that's available to you. That will be the answer. You can try searching online, but sometimes that'll be outdated information or incomplete, or sometimes people are just wrong on the internet. If you go to the source code, that is the answer. It cannot possibly be wrong because this is the code that your program's running to use the math library. And you notice the math library has this class. We use it as a library, so I call it a library usually. But this class has some public static final variables. So I say all of your instance variables. Actually, I don't think I did say that in this lecture today. But all of your instance variables should be private. With the getter and setter conversation, they should be private for control. I don't think I explicitly said make all of your instance variables private, but make all your instance variables private. They got to be private. That's the Java way to do things. You can use protected, or we saw transient came up here, but in 116, they're all going to be private. But here in the math class, they have public variables, and this is actually okay. This is okay to do. One, these are not instance variables. They're class variables because they're static. But more importantly, they are final. Final means that this is a constant. We cannot reassign it, just like the one we just saw in the array list class. So this is since it's a constant, giving everybody access to it doesn't matter because nobody can say math.e equals and override this value because they'll get an error because it's final. So we can make constants public. That's perfectly fine. There's no harm that can be done making a constant public. That's fine to do. And just notice that we do have this available to us. If you ever need e or pi in your code, don't type it out manually. Don't create a variable called pi and do like 3.1415, and that's probably where you're going to stop, if not at 3.14. Use math.pi. If you use math.pi, you'll get this much precision, which is as much precision as you can fit in a IEEE double. This is as much as you can fit in those 64 bits. Same with e. Math.e is going to give you that constant to as much precision as you can fit. And the last thing I want to talk about, math has a private constructor. So even if you wanted to, for some reason, you cannot say new math. It's not going to let you because the constructor is private. Not allowed to do it. Whereas you could technically, in your task 1, you can say new problem set and create an object of type problem set, but it just doesn't make sense to do so. Even though you didn't write, we're kind of tight on time, but even if you don't write a constructor, you get the default constructor, which takes no parameters and doesn't do anything. So that's why math explicitly writes a constructor and makes it private instead of just not writing a constructor at all. If you don't write a constructor, you do still get one. You can test that in your problem set 1 in your testing, the test problem set class. You can say new problem set and it'll work just fine. It won't do anything useful for you, but you can do it. There's no reason to, but you can. All right, so let's set up this. I'm going to try to type the code pretty quick here. I spelled that wrong. Refactor, rename, my brain is just stalling on that one. Character, yeah, sure. What I want to do is set up a little bit more complex RPG example where I'm going to have a party of characters. Party is going to have my main method in it. What I want is characters. Actually, character, I can write my main method first. Character, week 4 lecture, didn't get imported, cool. And I'll try to just create this the way it is in the slides. I don't want to really do anything new here. Anything different than I did last time. Character, I have to cheat a little bit. I don't take anything here, right? Yeah, I just use the default constructor. Just to make sure. Hero equals new character. Don't even have to do that. Let me just explain it here. I don't want to trace it though. If we do this, just very quickly, this concept called garbage collection, if I lose access to an object on the heap, if I no longer have access to its references, so here I'm creating a new object, putting it in the hero variable, and then immediately reassigning hero to a new variable, that means this first character I created, because I created 2 objects, I only have 1 variable, this first object, I no longer have a reference to it, and whenever that happens, Java is going to garbage collect it. It'll go to the heap, find any objects where we no longer have the ability to access it, if we don't have any references to it, and it'll remove it from memory and free up that memory for use of other objects. Fighter equals new character, which is a very handy thing. It's not something we really have to think about in 116 unless you want to, of course, if you want to learn more. And I'm always happy to answer questions about things like that. But by default, I won't talk about it. It's not required in the learning objectives. But in 220, you will learn a lot about the garbage collector. You will be writing in the language C, which you'll learn a lot about the garbage collector because C does not have garbage collection. So you're going to realize how much the garbage collector has been doing for you in Python and in Java, which both have a garbage collector. When you don't have it, that's the only time people really think about the garbage collector is when it's not there and you have to manage your own memory and clean up your own objects in, well, not objects in C, but you have to free up your own memory. That's when you feel it. All right, so let's write some character stuff. I want a few instance variables, private battles1. I'm pretty much just recreating the code in the other examples. Battles1 equals 0. I'm going to initialize this inline because my constructor isn't going to take any parameters. And int xp equals 0. So I want to check how many battles they won, how much XP they have, how much experience points. And I'm going to create a party of characters and then have them win battles both independently and as a party, and watch what happens in memory during all that. And we have the default constructor. I actually don't have to write one, but I am going to write one anyway just to make sure it's explicit that we do have that constructor. And then public win battle. So whenever we win a battle, I want to know how much XP that battle is worth. I don't have a return value, which is going to be void. And this dot battles1, whenever we win a battle, I'm going to increment battles1, and my XP is going to be equal to XP plus the XP that we just gained from this particular battle. And that's the end of my character class. That's all I want in there. Let me double check just to make sure. Oops, I'm on the wrong sides. I'm too afraid of forgetting something. Yep, no, that's all I need. And then party is going to have a few instance variables. It's going to have private int battles1. So I want to know how many battles the entire party has won, which is going to be 0. Oh, which is going to be 0. And we're going to see our next concept. This concept has a fancy word, but it's really just an implication of things that we've already seen. It's called encapsulation. What this means is if you have an object with an instance variable, and that instance variable is a reference to another object. So I'm going to have an array list of characters. And the fact that I have an instance variable that is a class type, we call that encapsulation to be fancy, I guess. But it is absolutely something we can do where objects are composed of other objects. So array list, characters, members, and I'm not going to initialize this here. In the constructor, I will initialize it, so the party constructor, there's no reason to do it in the constructor, but I just want to show different ways of doing things. You can initialize things here, initialize things in the constructor. Both are fine. Party, this dot members equals new array list. And that got my import that time. I wasn't worried about my import because I knew it would get it right there. Public when battle. Actually, before we do that, public add character. So I want a way to be able to add characters into that array list. So character, I guess just character is the most descriptive thing. And this will return void. This dot members dot add, we're going to add to that array list this character that we just got. And then win battle. I do often forget my return type when the return type is void. Win battle, and we want to know how much XP that battle is worth as an int. And this dot battles won, so they won a battle as a party. And for I'll do it this way. It's this way in the slides too. I'm gonna still do it this way. So we can use a for each loop to iterate over this array list. I want to not use that because there are times in the class where you need to use the indices. So I want to make sure we have enough examples of that you don't forget how to iterate over the indices of an array list. So int I less than this dot members dot size, I plus plus. And then this is the big line in the trace. As long as we get, actually we're good on time, right? As long as we get to this line in the trace, we're going to be in good shape. This dot members, so we want to go to each member of the party and tell them that they just won a battle. So this dot members dot get of I dot win battle of XP. And my methods are appropriately grayed out now. I don't know why they weren't before. It was strange. All right, and I want to use some of these methods. So first, the hero is going to win a battle on their own. Let's say they win a battle and get 100 XP. And then we're going to create a new party. And I'm writing this code pretty quickly. If you're not keeping up with all the code, that's perfectly fine. I want to get through the code quickly so I can get to the trace where we're going to go through this code one line at a time and go through absolutely everything that it does. When I do this as slides, I click a slide and just boom, all the code just appears, and I say, let's trace this code, and I don't even go through it at all. So we do get more, you do get more watching the code getting written. But I still want to go through it quick to get to that memory diagram. So we're going to create a new party, and we're going to add our characters to it. Party.addCharacter hero. Party.addCharacter fighter. And finally, party.winBattle. And let's say they get 500 XP. Hey, and we're good. Looks like I didn't forget anything. We're good. All right, so let's trace this thing. Here. Show toolbar, trash can, hide toolbar. Get our character class. Go back to IntelliJ. Get our party class. Oh, I did copy instead of paste. I want everything. It should be at the OS level. When you copy instead of paste, if you're trying to copy empty string, it shouldn't copy anything. Wonder if that's a Mac thing, because my Mac, I feel like it's on my Mac it doesn't do that. I was wondering if it was on an application basis, or maybe it is at the operating system and Mac is just nice and Windows isn't. I don't know. But that's the behavior I want. Don't let me copy the empty string into my clipboard. No, yes, I should just be more careful, but it's something that I would never want to do. If I want to clear my clipboard, I would like copy a space character, just a blank space character. Anyway, all right, so let's go through this. We start at the main method. We have two different classes, so the question is which one is being executed. On your quizzes, I'm only going to give you one main method, so you can infer that that's the class that's being executed, that we ran this from the party class. So we have the main method, like every stack frame memory trace starts off in Java, is with the main method. We have a hero variable that's being assigned a new character, so we have another constructor call. We got 3 constructor calls going on here with no parameters at all, so we're not going to worry about parameters. We have hero, so we're going to create a hero character. Man, I really stumble on spelling character. Character, map it to the stack frame that doesn't exist yet. I always do this before I forget. At least when I get back there, I'm going to say, oh, this doesn't have a value. Uh-oh. So the stack frame, let's give the name here too. And when we create our character object, I want to get all of the instance variables. So battles1, which gets initialized to 0 right away, which it would anyway, because that's the default value for ints, but I'm not going to expect you to memorize all the default values, like I said before. And this is OX100. There are no parameters, so nothing else to put on the stack, and the constructor doesn't even do anything, so it just returns OX100. Then we get to fighter. Another character stack frame. With this, I don't know what this is yet, but I know it's going to be something. Create a new character, get its instance variables. Battles1 is 0. XP is 0. And map it to the dark blue constructor. OX200 is what I got. Return this to here, and we get OX200. We're ready for hero.winBattle. So hero.winBattle, from this object right here, we're calling winBattle. This object was OX100, so this is OX100. And winBattle, this is our first instance of many where we have to ask ourselves which method is going to be called. Because we have 2 methods called winBattle in our code, and we have to think about which one is going to be called. We want to make sure we don't call the wrong one here. So winBattle, first of all, I know the parameter is going to have value 100, but I don't know what the parameter's name is yet until I find the method. So to find the method, and you'll see me do this many, many times this semester, is we're going to look at the type of the calling object. This method is called from OX100. That's an object of type character. So we're going to go to the character class and look for a method named winBattle that takes an int. We find it right here, and this is the one that's going to be called. So the method that's called depends on the type of the object that called the method. That'll be true all semester. We're going to confuse things with inheritance and polymorphism when we get to those topics, and that's always going to be the same because there's going to be different types and a whole bunch of weird stuff going on outside of that, but that is always going to be consistent. The object, the type of the object that called the method, We're going to look in that class for the method that's being called. With inheritance, we'll add a step to that. With polymorphism, we actually won't, but we'll get confused with, you know what? I'm foreshadowing too much. Let's task at hand. So win battle, it's this method. So this dot battles 1 plus plus. This dot battles 1 plus plus. This dot xp plus equals xp. XP is evaluated, the right hand side is evaluated as a separate expression, starts over at the stack frame again, which is 100. And it's a relief to be able to say 100 instead of 100. These are hex values technically, so this is not 100. This is 100 in hex, which is, oh, why'd I open my mouth? I don't know. 250. Yeah, oh yeah, 255. Or no, 256. It's 256 is the actual value here. But I'm not going to say 256. I'm going to say OX100 because 256 is way more confusing. All right, so win battle, we get to the end of the method, cross this out, and go to our next line here. Party equals new party. So party, are we on time? 10 minutes? Oh, we got this. Party, object, party, constructor, party, instance variables, battles 1, and which is 0, and members, which doesn't get initialized yet. I'm going to leave it uninitialized. Technically, the initial value is null. We ain't going to write null and then cross it out. If you want to do that on your traces to be more accurate, that's fine. Not a requirement. We got OX300 as the reference to the object being created, and then the constructor is going to initialize this dot members equals new array list. So we're creating an array list just like we did before when it was in the stack, but we have a little bit more going on because this is being assigned to an instance variable. So this dot members equals new array list, but we still create the array list the same way we always did. Create the array list on the heap. We see the keyword new. We know we're creating an object on the heap, and we get the value OX400. That's what this resolves to, and that's what's assigned to members is OX400. So we have an object on the heap where one of its instance variables stores a reference to another object on the heap, which is an implication, just an extension and combination of things we already know. But when it does happen, it does, there's a lot of moving parts, a lot's going on with that one, especially when we get to the big line we're building up to. So this constructor returns, party is OX300, and party.addCharacter, party.addCharacter, we're calling addCharacter from this this object, which is OX300. So this is OX300. I feel like I have a typo, but I can't see it. Oh, no, I didn't. And that takes hero as a parameter, as this character parameter, gets the argument hero. Hero is a separate expression. We evaluate it from the stack frame, which is OX100, and that's what's passed, just the reference to the hero. And we're going to start seeing a lot of stack frames like this, where everything in the stack frame is a reference, instead of our primitives, which store values. We're going to see a lot more references, because pretty much everything's a reference moving forward. We'll still use our primitives, but a lot more references. And then add character is going to do this dot members dot add. Our first time seeing multiple dot operators in the same line. Now you can all figure out, you can all infer what this is going to do, and same with this line. I think you can all infer what that's going to do and figure out what it will do. But it's important that we focus on how exactly it does do what it does. So this dot members dot add is this dot members. So this dot members, this whole thing resolves to OX400, and the dot operator will say whatever's to the left of me resolved to a reference take me to that object. So this dot members, that whole thing resolved to the reference OX400, and this dot operator says, take me to the object at OX400. Takes us to this array list, and we're calling add from this array list. Add is internal to Java, so we don't trace the add stack frame, even though it technically happens, but you do just have to know what the add method does for an array list. So add is going to take this value and insert it at the next available index, and that reference character is resolved at the stack frame. It's a new expression, so we go back to the stack frame and evaluate character to OX100, which is inserted at index 0 in this array list. OX100 at index 0, and then this stack frame ends. We go to the next one, add character of fighter, party.add character. Add character. This is OX300, reference to the object that called the method, and the parameter, I'm too afraid of trying to spell character again. It gets fighter, which is OX200, and then this dot members dot add character, which is OX200. So at index 1, we get OX200. And finally, the big one, party.win battle. So party.win battle. So we have win battle from OX300. And win battle is called from this object of type party. So we go to the party class and find win battle that takes an int. And our parameter name is XP still. Gets the value 500. This dot battles 1. Increment that to 1. They won 1 battle as a party. And then we get to this loop. We're getting to the good stuff now with only 4 minutes left. But we got this. We're going to create our code block because we do have a variable declared in the code block. The initialization statement for a for loop is executed inside the code block for that for loop. So I equals 0 inside the loop. I less than this dot members dot size. This dot members dot size is 2. 0 is less than 2. That's true. So we are executing the loop. So this loop, this line right here, ooh baby. And we just break this down one step at a time because there's a lot going on. And again, I'm sure you can all figure out that this is going to call win battle on both of the objects here. And they're both going to get their 1 battles 1 and 500 more XP. But let's figure out exactly the mechanics of how that works. Because in the quiz that I give you, you might not have the context. With the context, you can infer what's happening because there's context clues all over the place. But if this were stripped of all the context clues, it'd be a bit harder to figure out what's happening without actually tracing through the code. So this dot members resolves to OX400 dot get. So we're calling get, the get method from this array list right here. So this dot members dot get is calling get on this array list. The argument is I. That's a new expression. We start over at the stack frame. So we have I, which is 0, so we're getting the value at index 0, which is OX100. So this entire thing right here, this dot members dot get of I, resolved to OX100. So this dot operator says whatever's to the left of me resolved to a reference, take me to that object. It doesn't care that it bounced around twice in memory and then called a method that resolved to a reference. It doesn't matter. It resolved to a reference. It's OX100. Dot says take me to that object, and from this object here we're calling win battle. So win battle, where this is OX100 and XP is 500. That's going to do this dot battles 1 plus plus, this dot XP plus equals XP, so that's going to increase to 600. This crosses out. We hit the end of our loop, increment x to 1. 1 less than 2 is true, so we're doing this again. We're doing this dot members dot get x, or I, which is 1, so we're getting OX200 dot win battle from this character. So now we call win battle where this is OX200. It's an object of type character, so we're calling this one XP is 500. This dot battles 1 plus plus. This dot XP plus equals XP, which is 500. This returns. The loop ends. Increment X. Ooh, I missed that in the previous lecture. The increment X to 2. 2 less than 2 is false, so the loop breaks. X is removed from memory. Then we hit the end of the stack frame. The whole stack frame is removed from memory. Then we hit the end of the main method. The whole program is removed from memory. Whew. Right at 1:30. Got there. I had to rush the end a little bit. But we did get everything out there. And I'm going to take half an hour here, and I'll see some of y'all. If I don't see you in office hours from 2 to 3, I'll see y'all on Tuesday. All right, have a great day, everybody. Whew, what a lecture. We got a lot of good stuff. If you followed everything in today's lecture, you are doing fantastic, by the way. The expectation, especially if you didn't watch ahead, if you didn't watch this lecture before from the previous videos or previous semester or anything, this is your first time hearing all this stuff, you should feel pretty overwhelmed. So there's just a lot. Private versus public, static versus non-static, constructors, tracing constructor calls. It's just a lot all at once. And it's summer, so a whole week of content just went by in 2.5 hours. It's a lot. If you're not keeping up with that, definitely study, rewatch this lecture right away, get your test 2 done still before the expected. But you probably should feel a little overwhelmed today if it's your first time hearing all that stuff. So don't panic, don't fret. But do study. All right, take care, everybody. Have fun.